Hello everyone. Today let's solve the Leetcode problem number 898. Validate binary search tree. So what the question says, given the root of a binary tree, determine if it is a valid binary search tree, BST, right? So a valid binary search tree is defined as the left subtree of a node contains only nodes with the keys less than the node's key. One thing. The right subtree of the node contains only the nodes with keys greater than the node's key. Second thing. And both the left and the right subtrees must also be the binary search trees, right? So let's see how can we achieve this. So let's look into example number 1. So root, they have given 2, 1, 3, right? So here 1 is less than 2 and 3 is the left child node, right? And the right child node must be greater than the root. So it is greater than root. Here the node value is greater than root value, right? So this is true. Same goes with the example 2 as well, right? So I'll just take a simple example. Let me consider this example itself. 2, 1 and 3. So what are all the base case is, suppose if the node is null, so completely null, so we don't have anything in the node, so we are by default that is a valid binary search tree. We will return valid binary search tree, right? That is one thing. Second thing is, we will check whether the current node's value is outside the valid range. So if it is outside the valid range, then current node is outside the valid range, then we will just return the false. So constraint whatever they have given, if it is outside the valid range, then we are returning false. The third one is, we will recursively check whether this one, this node value, the left child node value is is lesser than the value of the root or not, and this right node value is greater than the root value or not. We will recursively check for every this thing, right? So here it holds true. So we'll do the same thing. So let's continue by writing the code. So I'll just give me a second. So I'll just come here. First case is, I'll just check whether if root equals null. What we will do? We will return true. The second case is, we will check if the current node's value is outside the valid range, as I have explained, right? So if the value of the root is less than or equal to minimum, or again value of the root is greater than or equal to maximum, then what we will do? We will just return false. So finally what we'll do? We will recursively check the left subtree, whether the left subtree with the maximum value and the right subtree with the updated minimum value. So how can we do that? I'll just give a return is valid root dot left minimum and root dot right. Also we have to check for the right subtree as well, right? So I'll just come here. Is valid BST. So I should have copied the function name itself. It's fine. Root dot right value of the root along with the maximum, right? This is fine. Let me format the code once. Let me hit the submit. So everything works correctly, right? So what would be the time complexity and the space complexity? The time complexity would be big of n. Why the time complexity is big of n? Because each node is visited once, as I have showed you in the by taking the example, right? So where n is nothing but the number of nodes in the tree, right? So the overall time complexity would be big O of n. What is the space complexity? Space complexity would be big O of h, where h is the height of the, nothing but the height of the tree. Why the space complexity is big O of h? Because this, we are making use of the recursion stack, which is proportional to the height of the tree. So I'll just come here. Let me give time complexity. Overall time complexity is big O of n. Space complexity is nothing but big O of h. So yeah, just let me comment this one. So yeah, this is it. Thanks for watching, guys.